Yes, so here we're going to discuss number 11, part E, because we have completed number 10 via discussion, and moving on to number 11, part E. Number 11 now is a question related to correlation between two variables. If you have to compare it with number 10 dealing with measures of central tendency like mean, median, mode, and measures of dispersion like range, interquartile range, variance, and standard deviation. Now, these two descriptive measures, meaning central tendencies and measures of dispersion, only need one variable to do the calculation, right? It's analyzing only one single variable. But with correlation and regression, which is what number 11 is all about, you must have at least two variables, X and Y. And it's all about measuring how they are correlated between each other, how one variable affects the other. The X will be the independent and the Y will be the dependent. There are different ways of doing that. And part E now is focusing on the Spearman's coefficient of rank correlation. That's one method. Another method is Pearson's product moment, which is later down in number 11. So number 11, part A, is about Spearman's coefficient of rank correlation. And you can get assistance in week 7, page 1 and 2. Okay, but here assistance is provided, explanation is provided, starting with a definition. The coefficient of correlation, right, gives a measure of degree that two variables, right, X and Y, are related to each other. This value cannot be less than -1 and cannot exceed the value of 1. So any calculation you make for correlation must be within those parameters. Well, -1 and 1 included. -1 will be perfect negative and +1 will be perfect positive. You have strong and weak, negative, positive, and no correlation. So now how do we perform a Spearman's coefficient of rank correlation? This method measuring correlation is relatively simple compared to Pearson's product moment. Steps to calculate Spearman's coefficient of rank correlation: create two columns, two more rows. You'll have two rows already, or columns, X and Y, but then you have to create two more, which are called rank of X and rank of Y. And how do you rank? The highest value gets a rank of 1, and the second highest a rank of 2, and so on. This is done for both sets of data. A tie is when two same values are given the same rank when ranking a particular variable. The ranks of each corresponding data are then subtracted. So you have a third column or third row to calculate what is D squared. How do you calculate D? You subtract the ranks, rank X minus rank Y, and then that value, you square it, right, to cancel out any positive number, any negative number. So all your D squares have to be positive. And number 7, now you sum up all those D squares. And the whole idea is to substitute the sum of D squared into this formula. So here's the formula to calculate Spearman's rank. This first letter there is the Greek version of R for relation. It's called rho. Okay, because the R was already used, the English R was already used by Pearson's. So Spearman's used the Greek R, rho. So relation is equal to 1 minus the sum of D squares divided by n, open bracket, n squared minus 1. N is the number of pairs. Pairs mean X and Y. Okay, so here's an example, 7.1, as to how this is done. 10 students were interviewed. So N here is 10 pairs of values. The hours spent studying and the score was recorded. So one person, for example, said they studied for 3 hours and they got 55%. One said they studied for 9 hours and they got 95%, and so forth. So N is 10 because two variables were measured. Two data were taken from each of the 10 individuals, the hours and the score, to see how hours affecting score. All right, the relationship between the two. So here's the value, here's the data again in the solution. You have to add 3 rows, one for rank X, one for rank Y, that is 2, and one more, one for D squared. Now remember, you want to rank the X, the highest value gets a rank of 1. So you must have 1 somewhere. in the rank. And here it is, 1 because of 9 of 9. 9 is the highest X, so 9 gets a rank of 1. 8 is the second highest, so it gets a rank of 2. Now, since there are 3 8s, you have a tie, so each of them get a rank of 2. 2, 2, 2. Then 7 is the third highest, get a rank of 3. 6 is the fourth highest, get a rank of 4. 5 is the fifth highest, get a rank of 5. 4 is the sixth highest, get a rank of 6. But there are 2 4s, so you have 6 and 6. And lastly, 3 is the seventh highest, you get a rank of 7. All right, the highest value get a rank of 1. So just like X, you have to rank Y. There is this rank of Y, and you look from 55 to 95 to see which is the highest. 95 is the highest, so it gets a rank of 1. 80 is the second highest, it gets a rank of 2. 75 is the third highest, get a rank of 3. But if you notice, there are 275, so you have to scan the whole list of values to see if any values are repeated for them to get a tie. Here you have 75, and then you skip 70, 75, so you have a rank of 3. And then you come back to 70, which is the fourth highest, the rank of 4. 68 is the fifth highest. 63 is the sixth highest, get a rank of 6. And then you come back to 60, get a rank of 7. And then 55 is the eighth highest, get a rank of 8. And then you have 50, get a rank of 9. Now you subtract the ranks and then you square your answer. So 7 minus 8 will give us -1, and then you square that to get 1. So all the squares have to be positive. 6 minus 3, 9, 6 minus 9 is -3, minus 3 squared is 9, +9. So the d squared is 9. 6 minus 6 is 0, 0 squared is 0. 5 minus 7 is -2, -2 squared is 4. 4 minus 5 is -1, -1 squared is 1. 3 minus 3 is 0. 0 squared is 0. 2 minus 4 is -2, -2 squared is 4. 2 minus 3 is -1, -1 squared is 1. 2 minus 2 is 0. 0 squared is 0, 1 minus 1 is 0, 0 squared is 0. And then you sum up all those d squares to get 20. And n we know is equal to 10. And then you substitute into the formula. The formula comes with a 1 and it comes with a 6. The 1 is separate. So that's why it is bracketed there to make sure that it does not mix up with that calculation. So 1 minus 6 times 20, because the sum of this squared is 20, you got 20. 10, open bracket, 10 squared minus 1, because n is 10. 1 minus 6 times 20 is 120. And then you have 990. 10, open bracket, 10 squared minus 1 is 990. Then you divide 120 by 990, you get 0.12. And then 1 minus 0.12 is 0.88. Okay. And as you can see from the scale, this is strong positive because it is between 0.5 and 1. So there's a strong positive correlation between hours of study and score, according to Spearman's, because like the more you study, there's a greater chance that you'll get a higher score. That's what it means by a positive correlation, very strong positive correlation based on Spearman's coefficient of rank. So please practice this and then apply it to number 11. Number 11, part E. Okay. So apply now to part E. Part E is the same hours of score, but the values are different. Okay, you have from 5 to 22 hours, and you have 45 to 89. There are 2 89s. 98 is the highest, so that one not supposed to be there. That's an error. 98 is the highest, so that one's supposed to be under 98. So if the question wants to help you, that one's supposed to be under 98. Now let's look at N. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So N is 7. So that's where the formula helps you already. N is 7. 7 open bracket 7 squared minus 1. 6 times. So what you need to get is the sum of these squares. So you have to continue ranking, subtract and square, and then add to get the sum of these squares, and then to apply it to number 11, part A. Measuring correlation using Spearman's coefficient of rank. You must get a number between -1 and 1. All right, 0 point. Most likely it will be a positive 0 point something. Always bear that in mind. Coefficient cannot exceed 1 and cannot go beyond -1.